right, this is the Unit 3 review day 2 notes. Yesterday, or on the first video, we talked about the recursive and explicit equation. Today we're going to talk about series and whether it's finite or infinite and all that good stuff, and finding the sum of those series. So, when you have an arithmetic function and it's a series, it's going to continue to add the same number every time. And if I want to find the sum of that series, instead of adding up every individual number, all I have to do to find my sum is take our n value, which is the number of terms you have, times a sub 1, which is your first term, plus a sub n, which is my last term, divided by 2. Okay, now that's if it's finite. If it's infinite, it's going to constantly be adding the same number over and over and over again. So it's not going to have a sum because it's going to keep on going towards infinity. So no sum. Okay? So if it's arithmetic, you're going to either have one of these two answers here. Okay? I'm going to come back to this. I'm going to flip over so we can do a couple of my arithmetic examples. So first off, number 1, we have to determine, is it finite or infinite? Okay? Notice it goes 6, 11, 16, blah, 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 blah. There's no dot, dot, dot here at the end to tell me I'm going to keep on going. So that means this is finite. Okay? So it's finite. So to find the sum, we would do that equation. Our n value, so there's 1, 2, 3, 4, 5, 6 terms, times my first term, 6, plus my last term, 31, divided by 2. And so 6 plus 31 divided by 2 times 6 on the outside gives me 111. So that is the sum of that series. Now, we also talked about in Unit 3 is how to write summation notation, okay? So remember, summation notation had this symbol sigma, okay? And at sigma, you always start with n equals 1 on the bottom. And the largest number of terms that we have is what goes on top. So because I have 6 terms, I have the number 6 goes on top. And then the only thing that goes here is our explicit equation. So 5n plus 1. That's that summation notation there. All right, so let's look at my next arithmetic function. We have 101, 93, 85, 77, 70, 69, dot, dot, dot. So notice that means that it is infinite. Okay, so when it's infinite, you have to determine, is it convergent or divergent? Okay, convergent means that it's going to keep going on. Converging means it's getting smaller and smaller and smaller and smaller and smaller. Now be careful with that. It doesn't mean that my number's value is, it means like how that it's going to get down to like fractions and decimals and stuff like that. The size of the number, not the value of the number. Okay, so if it's divergent, that means it's going to keep on going forever and ever, and it's never going to come to a smaller number. It's never going to get smaller. So with arithmetic is always, 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 always divergent, because it's never going to come down, start out with this, and then get down to like 1/2, 1/4, 1/3, blah, 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 blah. Okay, so arithmetic is always divergent. So that means that because it's divergent, that means there is no sum, because it can't, when it's going to infinity, dot, 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 it's never going to find a sum. Okay, and so then to write our summation notation, we write our sigma, and n equals 1 goes on the bottom every time. And because I have this dot, dot, dot at the end telling me it's going infinite, that means I'm going to use the infinity symbol. And then we just write our explicit equation. So negative 8n plus 109. All right. And then my last arithmetic function, we have to determine, is it infinite or finite? Well, this one, it goes 29, 65, 101, 137, dot, 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 then 363. And it tells you that there's 10 terms. So when it goes dot, 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 and then 363, that's basically them saying it's going to keep on going, and then that's my last term. So that means that it is finite, because it's going to stop at 363. Finite. Okay? Which means that we can use that equation where we use our n value. So there's 10 terms here, so that means it's going to be 10 parentheses my first number, 29, plus my last number, 363, or 353, sorry, over 2. So, 29 plus 353 divided by 2 times 10 gives me 1,910. Okay, so that's the sum of that series. And then the last thing for our summation notation, again, we have sigma, n equals 1 goes on the bottom, and then our top number of terms, which is 10, goes there. And then our explicit equation, 36n minus 7, goes here, because that's telling me I'm going to plug in 1, 2, 3, all the way up to 10, and then you'll add those numbers up to write it as a summation notation. All right. So then I'm going to come back to the first page. So we've gone through all of our arithmetic examples. So we're going to come back to the geometric, okay? Now, if it's a finite series, you use the equation S sub n equals a sub 1 times 1 minus r to the n power over 1 minus r. So that means it's finite, it's going to end, so you always use that equation. If it's converging, remember that means it's getting smaller. That's S sub n equals a sub 1 minus, or divided by 1 minus r. 2. And then if it's diverging, remember that means my numbers are getting bigger and bigger and bigger, and there's no sign of getting smaller. In size, that means that there is no sum. Okay, so we have 3 different ones when it comes to geometric. So let's look at our examples. Okay. So, our first example, it stops at 2,916. There's no dot, dot, dot at the end, so that means it's finite. Okay, and so when it's finite, we use the equation a sub 1 times 1 minus r to the n power over 1 minus r. So, a sub 1 is my first term, which is 4, times 1 minus my r, which is 3, to the n power. So we have 1, 2, 3, 4, 5, 6, 7 terms. So it's minus 3 to the 7th power over 1 minus 3, because again, 3 is my ratio. So again, I always take this one piece at a time. I do the top of the fraction first. So 1 minus 3 to the 7th divided by 1 minus 3 times 4. Gives me 4,372. Okay, and then our summation notation follows the same process. N equals 1 goes on the bottom. My number of terms go on top, so there's 7 terms. And then my explicit equation is what goes at the end. 4 times 3 to the n minus 1 power. All right, and then the last one on this page, number 5, we have to look and say, okay, is it infinite or finite? Well, we've got this dot, dot, dot at the end, which tells me that it is infinite. And then we have to say, okay, is it converging or diverging? Is my numbers getting smaller, converging, or is my numbers going to continue getting larger and larger and larger, and is it diverging? Well, it goes 500, 100, 200, 4.8, and then the next one would be an even smaller number. So this is converging, which means I use the equation a sub 1 divided by 1 minus r. So my a sub 1 is 500 divided by 1 minus my ratio, which is 0.2. So 500 divided by 1 minus 0.2 to give me 625. Okay, and then the last part, our summation notation. Again, we write our sigma. N equals 1 goes on the bottom, and because it's infinite, that means we use the infinity symbol on top. And then our equation, 500 times 0.2 to the n minus 1 power. Our explicit function is what goes at the end. All right, so that's that second page filled out. That's day 2. We filled out the second half of the table. Okay, so we're going to flip over and fill out those last 2 rows, and then we'll do some more examples at the end on finding some other stuff, as well as finding the sum of a series when it gives you the summation notation. So back here, this is when we have to determine if it's finite or infinite. Well, at number 6, it's got that dot, dot, dot on the end. So that means it is infinite. And it's going 1/4, 1/2, 1, 2, 4, 8, 16. And then the next one would be 32, and then 64, and so on. So my numbers are getting larger, which means it is diverging. Okay? And when it's diverging, that means that there is no sum, because my numbers are just going to continue to get larger and larger and larger. And then my last one, my summation notation, we start at n equals 1. It's infinite, so we put our infinity symbol. And then our explicit equation, 1/4 times 2 to the n minus 1 power. And then our last example, we've got 30, 18, blah, 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 until it gets to 3.88, and it says that there's 5 terms, which means that it is finite because it stops at 5 terms. And so with finite, that means you use the equation a sub 1 equal times, 1 minus r to the n power over 1 minus r. So a sub 1 is 30 times 1 minus my ratio, which is 3/5, or 0.6, to the n power. There's 5 terms, so that's what n is, over 1 minus 0.6. Okay, so we do 30. We do the inside first. 1 minus 0.6 to the 5th power divided by 1 minus 0.6 times 30 to give me 69.168. That is the sum of that series. And then the last column, we have our summation notation, which we start with n equals 1. And then we stop at 5 terms. So that means 5 goes on top. And then my explicit equation is 30 times 3/5 to the n minus 1. Okay? So that is the biggest part of finding out geometric, arithmetic, summation, and all of that good stuff. So we had a lot of equations that we had to memorize and that type of deal. All right? So with 8, 9, and 10, we're going to be using, given the following information, we want to find the number of terms in the function. So like, for example, number 8 gives me a sub 1, a sub n, and s sub n. So a lot of y'all had troubles with trying to determine, okay, was that arithmetic or geometric? Okay, well, let's look at the sum equations here back on our first page. Okay, it gives me a sub 1. Well, both of these have an a sub 1. Okay, a sub n, only arithmetic has an a sub n. Okay, the biggest thing is that 8 doesn't give me r. So that's why I know it's not geometric, because geometric, both equations have an r value there. So that means this is arithmetic. So we're going to be plugging in to the equation s sub n equals n times a sub 1 plus a sub n over 2 to solve for the n value. Okay, so it tells me s sub n is 153 equals, we don't know what n is. It tells me a sub 1 is 5 and a sub n is 29 divided by 2. So I always just simplify what's inside the parentheses first. 5 plus 29 divided by 2. That gives me 153 equals n times 17. So the last thing to do to solve for n would be divide by 17. Which gives me that n is equal to 9. So that means there is 9 terms in that series or sequence. Okay. Number 9, we've got a sub 1, a sub n, and s sub n. So same thing as number 8. It's arithmetic because I'm not given my r value. So again, we're going to use the equation right up here. So it tells me s sub n is 231. We don't know what n is. A sub 1 is 41. Plus a sub n is 36 divided by 2. So I'm going to simplify inside my parentheses. 41 plus 36 divided by 2 gives me 231 equals n times 38.5. And we'll divide by that to both sides. So that gives me n is equal to 6. So there's 6 terms in that series. All right, and then my last problem, notice this time I've got an r value, which tells me that it is going to be a geometric function. Okay. So 1 equals 12r and s sub n. Okay, so with geometric, that means we use the equation s sub n is equal to a sub 1 times 1 minus r to the n power over 1 minus r. Now, the reason why I know to use that one is because it gives me a number of terms. That means it's not going to be finite. Now, if it had told me that it's a finite, or infinite, sorry, if it was infinite, then I would use this one to solve for whatever it's asking me for. But because we are looking for a specific number of terms, that means it's going to stop. So that means I'm going to use this equation here. All right, so we got our s sub n is 84 equals a sub 1 is 12 times 1 minus 2 to the n power over 1 minus 2. All right, so first thing is I need to get rid of what's on the outside of the parentheses. So I'm going to divide by 12 to both sides. So 84 divided by 12 gives me 7. So that's 7 equals 1 minus 2 to the n over, and I'm going to go ahead and simplify 1 minus 2, which is negative 1. And then we start solving. So I'm going to multiply by negative 1 to both sides because we don't like the fraction, so we get rid of it. So that becomes negative 7 equals 1 minus 2 to the n. Okay? Then we need to start getting this exponential by itself because this is going back to our logarithmic functions where we subtract 1 to both sides. So that's negative 8 equals negative 2 to the n power. And before you can turn it into log form, you have to divide by negative 1 because we got to make it positive. So that's going to become 8 equals 2 to the n power. And that's when we convert it to log form, which we talked about in the last unit, where you start with your base. So log base 2 of 8 is equal to n. Remember to do that in your calculator, you do log of 8 divided by log of 2, which n is equal to 3. And that's the most complicated that it gets as far as finding the number of terms, so that's why I only gave you one example there. Okay, and then on the last page of the review, we're going to evaluate the series. Okay? And so that's when I'm given my first term, my last term, and the equation to plug into. So we are constantly plugging into our equation. 5 times 1 minus 1. 5 times 2 minus 1. 5 times 3 minus 1. 5 times 4 minus 1. 5 times 5 minus 1. 5 times 6 minus 1. 5 times 7 minus 1. And so I'm going to go ahead and tell you what those answers are because I've already done this problem. I'm assuming you know how to plug this into your calculator. So that's 4, 9, 14, 19, 24, 29, and 34. And so to find my final answer there, when it tells you to find the series or to write out the series, you would just write 4 plus 9 plus 14 plus 19 plus 24 plus 29 plus 34. But when it tells you to evaluate the series, we want what the actual sum is. So we do 4 plus 9 plus 14 plus 19 plus 24 plus 29 plus 34. And that gives me 133. So that is the final sum of my series there. Okay? So we'll do the same thing for the next one, for number 12. But this time, we've got x equals 3 at the bottom. So that means I'm going to start by plugging in 3 first. So we're not starting at 1 like this one. We start at 3. So 3 plus 5, 4 plus 5, 6 plus 5. So that's going to give me 8, 3, 4. Oh, I totally skipped 5 plus 5. There we go. 8, 9, 10, and 11. So the actual series itself is 8 plus 9 plus 10 plus 11. And the final sum of that is 38. And that's the final answer there. Okay. And then the last one, number 13, we start at 0. So that becomes 0 squared plus 1. Then we go all the way up to 8. 1 squared plus 1. 2 squared plus 1. 3 squared plus 1. 4 squared plus 1. 5 squared plus 1. 6 squared plus 1. 7 squared plus 1. And then 8 squared plus 1. And so the final answers to those are 1, 2, 5, 10, 17, 26, 37, 50, and 65. And you would add all those up to give you 213 as your final answer there. So if you add all these up, you should get 213 as your final answer. All right, so that's the last page of the notes. I forgot to go over the day 1 classwork on the first video. So the day 1 classwork, all you're doing is telling me, is it algebraic or geometric, and then tell me what the 10th term is, which means you're going to need to know what the explicit equation is there. On Thursdays, you're using 1 through 5 and giving me the explicit equation and the recursive. Don't forget, the recursive function has 2 different equations to it. Okay, so that is the day 1 classwork. The day 2 classwork, you need to find the sum of the series. So before you can do that, you have to determine, is it arithmetic or geometric? And so is it converging or diverging, and all of that good stuff to determine, does it have a sum, which equation do I use, all of that good stuff for 1 through 5. Number 6 or 1 through 9 here, whatever these numbers are. My printer didn't print out right, but hopefully yours does. This right here is you just rewriting the series. So is it 1 plus 2 plus 3? Is it 5 plus 6 plus 7? All that good stuff. And then here, you're actually evaluating it. So I want the final sum. I want that final answer there for that last page. All right, again, if you have any questions, comments, or concerns, please feel free to message me and let me know. All right, y'all have a good night. Bye.